All right, so our main focus today is going to be on calculating the probability for a binomial distribution. That means we have to figure out what a binomial experiment is first. A binomial experiment has certain characteristics. One part of a binomial experiment is that has a fixed number of trials, which is going to be considered your n. Focus on these letters because on all of the problems we're going to be doing or you're going to be doing this week, we're going to be thinking, what is our n, what is our p, our q, and our r. So n is the overall trials. Number two, the trials are independent and repeated, so no trial influences another trial, and they're all under the same environment. Each trial has exactly two outcomes, hence the binomial idea, two outcomes, one failure and one success. Next, for each individual trial, the probability of success is the same probability of success. That doesn't make too much sense there, but the probability of success is going to be your P. It's going to be a certain percent. So one of our students has the probability of success as 20% of throwing the baseball. And then the probability of failure is your Q, which would be 80% because 20 plus 80% gives you 1. And the last one is going to be the central problem or question of a binomial experiment is to find the probability of R successes out of n trials. R refers to the number of successes in your experiment. So you have n, total number of trials. R, how many successful trials you have. P, what's the probability of your successes. Q, what is the probability of your failures. And you may have seen this before, P plus Q equals 1. There are ways, that's basically 5.1 on what a binomial experiment is. And so you're thinking about those ideas. 5.2 gets into actually calculating the binomial probabilities. And so there are two ways that I'm going to go over today of finding it. One is with a formula, and the other one is going to be with your table, which you have in front of you. There's a third way that I'm not going to get through today, and that's going to be with your graphing calculator, which I'll show you another day. The formula for finding out a probability of a binomial experiment or distribution is where you have a combination of n items taken R at a time times the probability of success, which is your P, to the power of R, which is the number of successes, times Q, which is your probability of failure, to the power of n minus R, which is going to be actually the number of times it fails. And this will make a lot more sense when we go through a problem. The combination is here because you can have your probability of successes in a different pattern within the number of trials. And so that's why you have to multiply it by the combination. Then you're going to have a table, and in the table you have to know 3 pieces of information, your N, your P, and your R, and based on those 3, you can get at your percentage. Now, there are limitations of the table. The table only goes up to 20 trials, and it only has multiples of 0.05 in terms of the probability. So you're going to see when you're looking at this table, here's your formula. This is your N. This is your R. It's out of the N. and then your P is going to be up on top, and notice that you're having these as multiples of 5. So there are limitations to it, but it can solve a lot of your problems if the problem is within here. Good. Let's go to a couple of, so what the pros and cons of each. The pros of the formula is you can get exact answers. It's more versatile. You can use it for practically anything. The cons would be that it takes longer. The table, the pros of the table, this is quick answers. The cons would be probability is restricted. Trials are restricted because it only goes up to 20. Less than 20, and this would be multiples of 0.05. Let's go through a problem and think about solving it by formula and table. So let's say a student here has a probability of 20% on throwing a strike. And so our p-value is going to equal 0.20. That means our failure is going to be 0.80. And let's say that this student is going to throw the baseball 5 times. So the total number of trials, n, is going to equal 5. And the question is, well, we can ask quite a few questions. One question would be, what is the probability that this student will throw 3 strikes in the 5 pitches? Exactly 3 strikes. So exactly 3 strikes means your R is going to be 3. That's the number of successful trials. And to answer that, you can do it by using the formula. Now, if I think about this, my answer is going to be 0.2 times 0.2 times 0.2 times 0.8 times 0.8. 5 trials, 3 successful pitches, 2 that are not successful. That's longhand on how to do the problem. But the problem with this listing it out is there are different ways of getting those 3 strikes. We're not saying the student has to throw strikes the first 3 pitches. We're saying it can be anywhere in the 5 pitches. Because it can be anywhere in there means that you have to multiply this by the combination of 5 taken 3 at a time. Because that's going to give me the number of ways those 3 can be situated in that grouping of 5. Now, I can shorten this, and I can shorten it by the combination 3, 5 times 0.2 to the power of 3 times 0.8 to the power of 2. That right there is the formula that we talked about before. It's the combination times the P to the R power times the Q to the N minus R power. It's the same thing as where the formulas come from. The formula makes sense on solving these problems. The table, you're just looking up a number. Formula actually makes sense. So let's say, all right, I want to calculate that on my calculator. I could say, all right, it's going to be 5 3 times, and then it's going to be 0.2 to the power of 3 times 0.8 to the power of 2. And when I do that, I'm going to see that this student has a 5.12% chance of throwing 3 strikes in 5 pitches. Exactly 3 strikes. So that would mean that this is going to be 0.0512 would be the probability of the event occurring. What about the table? So that's longhand, that's formula. Let's go to the table and see what I'm looking at. 5 is so my numbers are 5 for my N, which is right here, 3 for my R, which is right here, and then 0.2 for my P up on top. So where that intersects is going to be right here, 0.051. Same thing that I calculated before. Well, let's say, for example, the question isn't exactly 3 strikes. But let's say the question is, what about the student getting 3 or more strikes? What would be the probability? Well, 3 or more strikes, that just means I want to take this number, add it to the 4, and add it to the 5 strikes. Add those 3 up, and there's my probability. That's pretty easy. What about if the question was, what happens if the student gets no more than 1 strike? No more than 1 strike. Well, let's see, no more than 1 strike. No more than means I can get 1 strike or less, which means I would add these 2 up. A table is very easy to use if you have like cumulative percentages that you need to add up, because you can just see them right in the table. Formulas, you'd have to go back and add. Let's think about another problem. And this problem is going to be where we have a multiple choice type of question. So I have 5 answers. There are going to be 10 questions. And the question is going to be, what is the percent that a student will have to blindly guess on each question and score 60% on a test? You may have had other students or friends say, oh, I didn't even study for that test and I got 80%. I just guessed on everything. Well, now we can see what type of chance they would have in terms of just guessing if all of the answers were equally likely. Sometimes you can get rid of some, but assuming that they're equally likely. So 60%, let's say passing at 60% or higher. So the question is, when does that person pass? What is the probability that that particular student will pass? Well, that means that you're going to have the probability of getting 60%, probability of getting 70%, 80%, 90%, or 100%. Well, it's got to be pretty high then if it's going to be all those different percents. What is the P in this problem? Well, with 5 multiple choice answers, getting the correct answer means it's going to be 1 out of 5 or 20%. So my P is 0.2, my Q is 0.8. Always want to identify what I'm talking about. My N is equal to 10. Yeah, P plus QI is equals to 1. Successes and failures would equal the whole thing. So at this point, I want to look on the table and find out what my answers are to see if my friend who's so smart and thinks they can pattern well can pass based on what we have here. So I'm going to go to 10 for my N, and I'm going to see, let's see, I've got to know my P. Okay, my P is 0.01 and 0.05. So when I go to 10, let's see, 0.01, 0.05, 0.10, okay, 15%, 20%. This is the column I'm looking at right here. Oh, I can't mark it. This is the column I'm looking at right here, which basically means that that if you get 60%, you're basically looking at, no, I forgot where I got right here, 0.006 as the chance of getting 60% on that test, meaning 0.6% of getting 60%. And 70%, you have a whole 0.1% chance of getting it. And 80, 90, and 100, you're off the charts in terms of such a small number being the probability. What's the probability of passing this test? 0.7% chance of passing if you guess on all those 10 questions. You can tell that friend of yours who told you that it's easy to pass just by guessing that they ate a bologna sandwich for breakfast in the morning. So you know it's not possible, and they're speaking a bunch of garbage. Now, if the question was, what was the probability the student got 30% or less by doing this? What you could do is look at that same column and go up to the 30%, 3 out of 10, and add the 0.2, 0.3, 0.2, 0.1, all of those numbers up, and you're going to see that probability is very, very high. In fact, it'll be like 99% or so. Again, in the problems, you're always looking for what is your probability, what is of success, what is the probability of failure, what are the number of trials, and how many trials at a time. And if you can identify the N, the R, the P, and the Q, solving these problems should be pretty straightforward. Tomorrow we're going to go over how to do this with the graphing calculator, and then the choice will be yours.